Let's begin. Today is October 27th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 9, 13, 16, 19, 20, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our 3-digit solution, and the Turing machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card B will take a look at our middle and last digits, the square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card C, again, will take a look at our 3-digit solution, except this time it'll give us a little information about the ratio of even to odds. Are there more even than odds, or are there less even than odds? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? Next, criteria card E, again, we'll take a look at our 3-digit solution, but this time it'll give us a little information about its structure, so to speak. Specifically, there are 3 cases. One where there are no repetitions in our code, as in the example 125, or it could be a double number where there is a repetition, as in the example 112, or finally, it could be a triple number, a single digit repeated 3 times, as in the example 222. And finally, criteria card F, again, takes a look at our 3-digit solution, and from triangle to square to circle, and it'll give us some details about the ordering of the digits. And again, there are 3 cases. The first case is where the digits are in an ascending order, meaning that they are increasing, as in the example 135. Or it could be that the 3 digits are in a descending order, meaning that they're decreasing, as in the example 421. Or it could be that the 3-digit code has no order. And so let's take a look at the example 231. Notice that it goes from 2 to 3, meaning it's increasing, but then it goes from 3 to 1 and then decreasing. You could also have something that's decreasing then increasing, but it's that shift from increasing to decreasing. That's one way that you could define a 3-digit code to have no order. We've also seen other puzzles where if you have consecutive digits, meaning digits that are next to each other, that are equal, that would also exhibit no order. So for example, if we take a look at, again, criteria card E as an example, 112, when you go from 1 to 1, there is no change. It neither increases nor decreases. So for that fact, codes that have consecutive equal digits also exhibit this concept of no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is I'd like to find out a little bit about the ratio of even to odds. So let's go ahead and test criteria card C. Okay, so the Turing machine does not approve of my choice. Notice that in 314, I do have 2 odds to a single even, but the fact that the Turing machine does not agree with that is actually informing us that there should be more even than odds. So let's go ahead and type that up in our notes for section C. And again, we'll say that there should be more even than odds. And so what that means is that at a minimum, we have two evens and a single odd, or it could be that we're looking at a solution that is all even. And the next thing I think I'd like to test is criteria card E. See if there are any repetitions, or, is it a double or triple? So let's go ahead and test criteria card E. And so it does approve of my choice. Now, in this case, again, we're looking at repetitions or not. And in 314, they are all indeed unique. So there are no repetitions. So let's go ahead and type that up in our notes in section E. And we'll say that the solution has no repetitions. And what that means is that because there are no repetitions, those two even digits are distinct, meaning that our solution should look like it'll have a 2, a 4, and an odd. So we don't know the ordering of those three digits, but we do know we will have a 2, we will have a 4, and we will have an odd. And so it is interesting that we do have criteria card A, the number of threes. So at this point, there either is a 3, a single 3, or there is no 3 at all, meaning that that odd is either a 1 or a 5. And so what else could we test? Well, we know also from criteria card B that they can't be equal, so it's either going to be less than or greater than. But I think at this point, I think it may be best to test criteria card D and see what that tells us. Okay, so it does not approve of my choice. So my triangle digit 3 and my square digit is 1. If I add those two digits together, I get a sum that's 4, which is less than 6. But of course, the Turing machine does not approve of that. So that means that the sum of the first two digits is either equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section D. And again, we'll say that triangle plus square should be either equal to or greater than 6. And let's see, can we say anything about that? Yeah, I don't think we can cross out anything, unfortunately, because, you can still keep a 1 and a 5, because that equals 6. And then, there's so many choices for values that are greater than 6. So yeah, I don't think we can actually cross out anything. Well, it is unfortunate, but we do have some clues going into round 2. We did complete our 3 Turing tests for this round. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So again, notice we didn't test how many 3s there might be in our solution. We also did not compare our middle and last digit. And of course, we also have that ordering criteria card F. And so, again, one of the typical things that happens when you have, a 2 and a 4 is that potentially the sum of the first two digits is equal to 6. But let's see. So if the sum of the first two is equal to 6, we know it'd be 2 and 4 in some order. And then that circle digit would be the odd digit, whether it's 3 or not. So let's see, is there a way, if we knew what square root was, maybe we could figure out what circle might be. So it could be something like a 2 and its square is less than. So it could either be a 3 or a 5, or it could be a 4. And then square might be greater than circle, meaning that it's between 1 and 3. And again, you could figure that out. Now the question is, can we know for certain what triangle and square would be? Which one would be 2? Which one would be 4? Is there any such? I suppose maybe criteria card F, the ordering, would help us to figure that out. Yeah, it could be something like, again, 4, 2, and then 3 or 5. Or it could be 2, 4, and 1 and 3 for circle. So yeah, it could boil down to that. Let's see. Yeah, if it is 6, you could say, oh yeah, square is smaller than circle. And you still would want it to have no order. So yeah, I could see that happening. So for that fact, yeah, let's go ahead and try 4, 2, 5. I'm proposing that, yeah, the sum of the first two will be 6, and then that square is smaller than circle, and that there is no 3. So let's try that out, 4, 2, 5, and see if that works out. Okay, so again, the whole reason for this proposal is basically, again, testing criteria card D. Let's see, well, that is the whole point. Is there a way where we don't have to test it and still have confirmation? I guess we could postpone testing it. We could do that. Okay, let's see if we can do it without it. So let's go ahead and test criteria card B. Okay, so it is true. If you look at the criteria card, we're comparing the middle and the last square and circle. It is true that square should be less than circle since 2 is less than 5. So let's go ahead and type that up in our notes for section B. And again, we'll say that square should be less than circle. And so what can we say about that? Well, if square is to be less than circle, that means square cannot be a 5, because if square were 5, there would be no larger quantity for circle to be. And similarly, circle cannot be a 1, because if circle were 1, there is no smaller quantity for square to be. So at least we can cross those out. And of course, yeah, so that means that we're looking at some sort of a diagonal pattern, so to speak, between square and circle. Next, I guess let's see if there are any 3s or not. So let's go ahead and test criteria card A. Okay, so it is true the Turing machine approves of the absence of a 3. So yeah, so that means that there is no single 3-digit. That is a fact. So let's go ahead and type that up, and we'll say that the solution has no 3-digit. And so basically that means, hey, yeah, let's go ahead and cross out all of the 3s. So there can't be a 3 in triangle, nor square, nor circle. Okay. And now we have a sort of dilemma. Should we test F or should we retest D, and perhaps maybe we can deduce F? So at this point, yeah, there seems to be, a good amount of either, ascending, descending, and no order. But it really does boil down to whether the sum of the first two. I think that's a little bit more paramount at this point. So let's, retest D. I was hoping not to, but okay, yeah, so the sum is 6. So let's go ahead and cross out this portion of our notes in section D. It is a fact that the sum of the first two is equal to 6. Now we have completed our 3 tasks, but let's see what we can do. So if the sum of the first two is 6, and again we have a majority of evens, the only way you can add 2 quantities to equal 6 is if they're the same type. So it can't be 1, 5. That's not plausible. So it has to be the 2 evens. So let's go ahead and cross out all of the evens in triangle and square. So we can go ahead and cross that out. And then let's also cross out the 1 in square. Okay. And because we do have 2 evens, and well, let's see. Yeah, and we know that they are no repetitions. Those evens cannot be duplicated. That means that circle, it must be odd. Okay, wow, so that's very helpful because we can then cross out the 2 and the 4. Okay, so that does lead us to having circle 5. And at this point, I guess you have 2 possibilities. So let's kind of quickly just type them up. You could have an ascending order, which would be 2, 4, 5, because that does equal 6. Or you could have 4, 2, 5, and that's no order. Now, how can we deduce that? Well, in both cases, square is smaller than circle, right? If circle is 5, then regardless of what square is, that will be less than. So no rules broken there. None of them have a 3. Yeah, I think I do have to go to a third round, a quick third round. Well, let's see. Is there something? Oh, I think I may have an idea on how we can deduce. If our solution were to be ascending, meaning that they are increasing, we would definitely know that square would be less than circle. Now, that is the case, but, I don't think if it were ascending, you really wouldn't need this card to confirm that fact, because that would make this card irrelevant. If you knew it was ascending, that would be irrelevant. And the same thing goes for descending. If it were descending, then you would know that square should be less than. I think I got that backwards. Let's see. Yeah. If it's ascending, square would be smaller. And if it's descending, you would know square is greater than circle. So I think for that fact, I think we should be able to deduce, and I apologize, I probably shouldn't have written it in line F, but I think I'm going to write, we are going to deduce that the solution has no order. Okay. So yeah, so it's because of the way criteria card B and criteria card F sort of interact that we are able to eliminate the possibility of the three-digit solution being ascending or descending, because that would imply certain knowledge about the ordering of square and circle, and we can't have that. So yeah, for that fact, I am going to choose 425 as a solution. So let me go ahead and cross out the 245, and so I'm saying that the solution should be 425 based on that deduction. And I should say that, we could make these certain deductions at the very beginning. I just choose not to because I want to sort of interact with the criteria cards. And then I guess if pressed upon, then I do try to figure out, are there deductions that we can make, like what we just described in F. Okay, well, I think we're ready to verify. So let's go ahead and do that. So 425 as our solution. 425. Okay, that is correct. And how do we do versus the Turing machine? Well, we did have 6 tests, six criteria cards, and we did 6 tests. So that's always good when we tie in those quantities. We were able to outright deduce F. So let's go ahead and type this up. So we did C, D, E in the first round, and the first 2 were incorrect. And then we did A, B, and we redid D and deduced F. So let's go ahead and type that up. So again, C, D, E in the first round. So both C and D were incorrect. E was correct. We did A and B, and they were correct. And we retested D and deduced F. And so that D was the sum of the first 2 being equal to 6. So how do we do? Wow, so we tied it. Okay. Again, as I've mentioned in other puzzles, sometimes I'm surprised when it's that close. I would have thought maybe it should be longer. And sometimes when I do win by 2, I think, well, maybe the Turing machine should have been able to do it earlier. But who knows? But it was a win. And as I mentioned, luckily, again, I was about to go to a third round, and I did recall, comparing criteria cards like B and F to make that deduction of the solution having no order. So just in the nick of time. Well, what about you? How did you solve? What criteria cards did you choose? Did you choose a particular order and discover something interesting? I'm always looking for aha moments. Please add those to the comments. If you liked the video, please do give it a thumbs up. And of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.